Hello and welcome to this presentation on Object-Oriented Programming or OOP. Today we will explore key OOP concepts including classes, objects, inheritance, polymorphism, and design principles that are essential for creating modular, maintainable, and efficient software. Object-oriented programming is a programming paradigm that revolves around objects. These objects contain data and methods that operate on that data. OOP promotes better organization of software and allows for easier maintenance and modification. The key benefits of OOP include abstraction, encapsulation, inheritance, and polymorphism. At the core of OOP are classes and objects. A class acts as a blueprint for creating objects which are instances of that class. For example, imagine a class car with attributes like brand and year, and a method start that defines how the car starts. Objects are the actual instances, like my car, that use these attributes and methods to perform operations. Inheritance is one of the key features of OOP. It allows one class to inherit properties and methods from another class, promoting code reuse. For instance, if you have a class electric car that inherits from the class car, the electric car will automatically have all the properties of car plus additional features like battery life and charge method. Polymorphism allows us to treat objects of different classes as objects of a common base class. This is achieved through method overloading and overriding. Overloading happens at compile time while overriding occurs at runtime. For example, in method overloading, we can have multiple methods with the same name but different parameters. In method overriding, a subclass provides a specific implementation of a method defined in a superclass. Let's now look at the four fundamental principles of OOP: abstraction, encapsulation, inheritance, and polymorphism. Abstraction hides the complex implementation details and shows only the essential features, while encapsulation bundles data and methods, protecting the object's internal state. These principles work together to make software easier to understand and maintain. Design patterns are proven solutions to common problems in software design. They offer best practices for solving recurring issues and improving software flexibility and maintainability. Some popular design patterns include the singleton, factory, and observer patterns. These patterns can help make our software more modular and acceptable to changes. SOLID is an acronym for 5 principles that guide object-oriented design. These principles, single responsibility, open-closed, Leskov substitution, interface segregation, and dependency inversion, ensure that software is easier to maintain, test, and scale. By adhering to solid principles, we can build software that is both efficient and robust. Let's consider a real-world example of inheritance and polymorphism. We can create a class vehicle with a move method. Then we define two subclasses, car and bike, that each override the move method to provide specific functionality. This demonstrates how polymorphism allows us to treat different types of vehicles as a common vehicle object while each performs its own action. In summary, object-oriented programming helps us break down complex systems into manageable parts. By using key concepts like classes, inheritance, polymorphism, and principles like SOLID, we can create software that is modular, scalable, and easy to maintain. Design patterns further help in solving common design issues. improving code quality and flexibility. Thank you for your attention. Now I will be happy to take any questions you might have. Feel free to ask about any aspect of object-oriented programming, whether it's about specific concepts, examples, or how to apply these principles in real-world projects.